Okay, good morning. Welcome to
SuperMath169.
SuperMath169. So we saw an interesting problem, and it's a kind of a problem we really haven't seen too much of before. So I wanted to talk through it, even though you've already solved the problem. It says cone A has 2 times the radius and half the height of cone B. What is the ratio of the volume of A to B, of cone A to cone B?
Alright.
So we've done this kind of problem with symmetric shapes before. So I would say to you, well, a triangle has its sides doubled. What's the ratio of the area of the bigger triangle to the smaller triangle? And what's going on there?
It's 4 times.
How come?
Because when the sides are doubled, the area is quadrupled.
Okay. And I might say to you, I have a tetrahedron. One side, the side length of one is 3 times the side length of the other. What's the ratio of the volumes? What would you do there?
Well, then the volume is 27 times.
How come?
Because the side lengths are tripled, the volume increases by 3 cubed.
Okay, so when we have nice symmetry like that, we learned that length scales, however the length scaled.
Mm-hmm.
Area scales as the square of the length, and we've seen that a couple different ways. Volume scales as the cube. But here we have something interesting happening. We have 2 of the dimensions getting larger, and 1 of the dimensions getting shorter. So we can't have a real back-of-the-envelope way of thinking about this. So before you walk through your solution, what did you think was going to happen here? What did you think was bigger?
Well, I thought cone A was going to be bigger because it would have a larger radius, and that radius is getting squared in the volume.
Okay, so how did you solve this problem?
So first I'll draw the cones. So this is going to be cone A, and here's cone B. So for simplicity, made the radius be 3. And the height be 4.
Okay.
And here the radius is 6 and the height is 2.
All right.
First I'm going to check if these are actually cones. Like if you can actually have a cone like this.
Okay.
Because I can use the triangle inequality where I use these 2 sides and the diameter.
All right.
Diameter is 6, these are each 5, so yeah, it works.
Okay.
Here, these are the square root of 40, so it's 4 root 10.
How did you figure out that the square root of 40 was 4 root 10?
Well, because
Explain your math to me.
I mean it's 2 root 10. 2 root 10.
What do you do?
So it's the square root of 40, which is the square root of 8 times 5. You can use the 4 from there.
Okay. Now the square root of 40 is in between what 2 numbers?
It's in between the square root of 36 and the square root of 49. So it's in between 6 and 7.
Okay. Now, root 10 is in between what 2 numbers?
It's in between 3 and 4.
So 4 root 10 is bigger than what?
4 root 10 is bigger than, 4 root 10 is about 16. Or, no, it's 12, right, 12.
Is it bigger than 12 or less than 12?
A little bit bigger because root 10 is bigger than 3.
Okay, so 4 root 10 is bigger than 12. And what did we say?
We
the
said
square root of 40 was in between?
It's in between 6 and 7, so.
Okay.
So 2 root 10, 2 root 10. 2 root 10, this is a little bit bigger than 6 and a little bit bigger than 6.
Uh-huh.
And then these are exactly 6. So these 2 sides, this side is bigger than this side.
Okay.
So it works. These are cones.
Okay, that's fine. Good checking.
So now the volume. The volume of this one is 1/3 36 pi times the height 2. Cancel a 3 and you get 12. So this is 24 pi. So you have 12 pi times 2.
Okay.
So in here, the volume, it's 1/3 9 pi, because the radius is 3 times 4. This is 12 pi. The volume, this is cone A, and that's cone B. So it's 24 pi to 12 pi, which is 2 to 1. It's twice as big.
Good job. Good job. And now, let's see if we can work it out in general.
Okay.
So, draw your first cone.
So
Okay. And what do you want to call R and H? You can pick either one to call R and H. Whatever you want.
that's R, and that's H.
Okay. And what about the other cone?
This is H over 2 and 2R.
Okay.
So
So what's the volume here?
the volume here is 1/3 pi times 4R squared. It's pi r squared, that's the area of the base, times the height, H over 2.
And why don't you write up here what that simplifies to be?
That simplifies to be pi times 4r squared times h over 6. So it's pi times 2r squared times h over 3.
Okay. And what's the area or volume here?
Volume here is 1/3 pi r squared times h.
Okay. So that's actually already simplified.
Yeah,
So how do they relate?
we want this one to this one.
Yeah.
So pi times 2r squared times h over 3 over pi r squared times h over 3. Well, these over 3's cancel.
Okay.
The pi r squareds cancel. The h's cancel, so it's 2.
Okay. And that makes sense because this formula, 2 pi r squared h over 3, is exactly this formula, pi r squared h over 3
Except with an extra 2.
times 2. Okay.
Yep.
So sometimes when we look at these three-dimensional objects, they don't scale the same way. Or they scale, like the height scales differently than the base or something, and we just have to work through what that does to the volume. Sometimes you can work it through kind of hand waving, and sometimes it's good to do some specific examples. But anyway, good work this morning, huh?